Welcome back, guys. Today we're doing lesson 3.4 using the quadratic formula. Now we've been looking at different ways or different methods of solving quadratic equations. We've done factoring, we've used square roots, we've done completing the square, and today we're going to do the quadratic formula, just using the quadratic formula as our method. This one by far is my favorite. It guarantees that you get an answer no matter what, whether it's a real solution or imaginary solutions. It'll give you an answer. So this one is by far my favorite formula, my favorite method to solve quadratics. But obviously you need to know how to use all of the different methods. So let's go ahead and begin. In Algebra 1, you were introduced to the quadratic formula, except in Algebra 1, you didn't have to memorize it. All you had to do for the EOC was to plug in your A, B, and C values, and then you plugged it into the online system, and it would calculate your roots or your solutions for you. Well, that's not the case anymore. In Algebra 2, you're going to actually plug in values for A, B, and C into the equation and go ahead and solve them and find your solutions. Now, these A, B, and C variables refer to a quadratic equation in standard form, like ax squared plus bx plus c equals 0. This is a quadratic in standard form. And whenever we go to figure out what A, B, and C are, we need to make sure that the quadratic that we are given is in that form, where everything's on the left side and then on the right side you have an equal 0. All right? And again, this needs to be memorized. No way around it. You're going to have to just memorize it. I wish I could tell you there was another way, but there isn't. So make sure you memorize it. I'll be showing you a video in class in YouTube that may or may not help you memorize it, but I'll play it for you guys in class. All right, so let's go ahead and begin. So first problem. We want to solve x squared plus 3x equals 5 using the quadratic formula. All right. I recommend, until you memorize it, that every time you do a problem that has to do with the formula, that you write it down. That way you practice writing it over and over again until eventually you memorize it. So x equals negative b plus or minus square root b squared minus 4ac over 2a. All right. First thing we got to do is put this in standard form. So as you see, the 5 is on the wrong side. It needs to be over on the left. So the first thing we're going to do is subtract 5 from both sides. We're going to get x squared plus 3x minus 5 equals 0. At this point, we are able to evaluate what A is, what B is, and what C is. So A is 1. Remember, when there's nothing here in front of an x squared or an x or anything like that, if you don't see anything, there really is a 1. This is a 1x squared. Your B value is 3 and your C value is negative 5. So off we go to plug this in. Negative B, that's going to be negative 3 plus or minus square root B squared, that's 3 squared minus 4 times 1 times negative 5 all over 2 times 1. Now the rest of the problem really is just evaluating it using order of operations. So please, please, please remember order of operations. We do our parentheses, our exponents, then multiplication, division, then addition, subtraction. So let's go ahead and do that. Obviously, you're going to take care of what's under the square root first. We've got to figure that out. So there is an exponent there, 3 squared, that is 9. And then we've got negative 4 times 1 times negative 5. That's going to give me a positive 20. And 2 times 1, we can go ahead and do that one. So x equals negative 3 plus or minus square root of 29 over 2. There really isn't anything more that we can do here. Square root of 29, there's no excuse me, there's no perfect square factor that we can pull out. So this is it. This is in simplest terms. So your two solutions are x is negative 3 plus the square root of 29 over 2, or x could be negative 3 minus the square root of 29 over 2. And that's basically it. Okay? Now in this case, you are getting two solutions. You're getting a positive one, well, not a positive one, but one that is found using a plus sign, and one that is found using the negative sign. Let's take a look at example number 2. Example number 2, you're only going to get one solution. So this one is solving an equation with one real solution. So let me just go really back here for just 1 second. Here we had two real solutions as our answers, right? Here we're going to have a problem where we're going to solve and get only one real solution. So here's the problem. Solve 25x squared minus 8x equals 12x minus 4. Again, the first step is to move everything to the left so that we have this in standard form. So I'm going to subtract 12x from both sides. 12x from both sides. And this is going to give me 25x squared minus 20x equals, that goes away, negative 4. The next step is to add 4 to both sides. So that's going to be 25x squared. That's Mr. Perez there making noise in the office. Woo! Thank you, Mr. Perez. We're adding 4.
I'm the janitor.
Yes, we're adding 4 to both sides. So this is going to be in standard form now. He was emptying out the garbage in the office. All right, so now we're able to figure out what A is, what B is, and what C is. A is 25, B is negative 20, and C is 4. And so once again, hopefully you'll memorize this pretty quickly. The quadratic formula, negative b plus or minus square root b squared minus 4ac over 2a. So x equals negative b. This is negative 20. Please note that b is negative 20, so we're taking the negative of a negative 20, and we'll simplify that in just a second. B squared minus 4 times a times c, all over 2 times a. All right. So once again, the negative of a negative 20, that is going to be positive 20, plus or minus. Oh, this phone is going crazy there. All right, so here we got negative 20 squared. That's a positive 400. Here we have 25 times 4, which is going to give you 100, times negative 4, that's negative 400. And 2 times 25, that is 50. Now I want you to see something. The value under that square root is going to go to 0. Now this stuff that we have down here under the square root has a special name. It is called the discriminant. Okay, once again, this part down here, this one right here, b squared minus 4ac, has a special name, and that name is called the discriminant. And when the discriminant is 0, like it is here, instead of having two solutions, right, because 20, what's the square root of 0? Well, that's just 0. And 20 plus 0 is the same thing as 20 minus 0. It's just 20. You're only going to have one solution. So we're only going to have one solution, which is 20 over 50. Now we're going to reduce that, dividing by 10, and our answer is 2/5. So x equals 2/5. That is our one solution. Now you're saying, well, this is a quadratic that has one solution. What's up with that? What that means is, let's say this is 1 and that's 2. 2/5 is right around here somewhere, right? It's before we get to 1. We're just gonna eyeball it. So before we get to 1, it's gonna do something like this. So this is a situation where it just touches. It just touches the x-axis, only at one point. Obviously this is going to be much skinnier because look at that A. That A is 25, so this is going to go up really fast. Yeah, really, really fast. But again, just touching at the point 2/5, comma, 0. So again, when your discriminant, b squared minus 4ac, is exactly 0, your quadratic equation is going to have only one solution, okay? Because this part disappears and we don't need that plus minus anymore. If we go back to the first one, the discriminant here was positive 29. So here, let me put here, this discriminant is equal to 29. When the discriminant is greater than 0, in other words, when it's a positive number, you're going to have two real solutions. All right? So if this b squared minus 4ac discriminant is bigger than 0, like here, it's positive 29, you're going to have two real solutions. If the discriminant, this b squared minus 4ac, is equal to exactly 0, you are going to have only one real solution. Okay, again, if the discriminant equals 0, you're going to have just one real solution. All right? Well, what happens if our discriminant is less than 0? Let's go ahead and take a look at that. So example 3. Here we are solving an equation with imaginary solutions. So if I have solve negative x squared plus 4x equals 13. Once again, the very first step is to put this in standard form, move everything to the left. So I'm going to subtract 13 from both sides. And now I'm able to determine what A is, what B is, and what C is. And once again, hopefully you're memorizing this. Quadratic formula, negative b, excuse me, plus minus square root b squared minus 4ac over 2a. We have negative 4 plus or minus square root b squared, that's 4 squared, that's 16, minus 4 times a, which is negative 1, times c, which is negative 13, all over 2 times negative 1. Okay, so now we're just going to solve using our order of operations. This is 16. Here we have negative 13 times negative 1, that's going to be positive 13. And positive 13 times negative 4, that's going to be negative 52. So make sure you get this right. Be very careful. You're multiplying negative 13 times negative 1 times negative 4. And over here we have negative 2. And now we're going to do 16 minus our 52. That's going to give me negative 36. And this down here is negative 2. Now, before we move on, we do know how to simplify negative 36. We break this into the square root of negative 1 and the square root of 36, right? We're taking, remember, the little I out. We're pulling the I out. So the square root of negative 1, that is I, and the square root of 36, that is 6. So if I rewrite this, this would be negative 4 plus or minus 6i over negative 2. And we can actually simplify this even further by dividing every term, dividing the negative 4, dividing the 6i, dividing the negative 2. Let's divide everything by negative 2. So negative 4 divided by negative 2, that's going to be positive 2. 6i divided by negative 2, that's going to give you a 3. Now remember, we're gonna get the plus and the minus. So just do 6 divided by 2. You're going to get 3. You're going to get plus or minus here, so that doesn't matter. And then negative 2 divided by negative 2, that's just 1. So this is your answer. You have two complex numbers or two imaginary numbers. X is equal to either 2 plus 3i, or x is equal to 2 minus 3i. So when your discriminant, if the discriminant is less than 0, you will have two imaginary solutions. And graphically, what this looks like, and I'm going to go ahead and just graph this guy so you can see what that looks like. When you have two imaginary solutions, that means that there are no x-intercepts. In other words, the graph will never cross the x-axis. So if discriminant is less than 0, which means it's negative, you're going to have two imaginary solutions and no x-intercepts. Because remember, our x-intercepts only reference really the real solutions, and there are no real solutions. These are imaginary. So let's graph this guy just for fun because he's here. The y-intercept is at negative 13. So let's just count by negative 10 here. Again, all we want is just a general idea. So let's just say it's around there somewhere. All right. We can easily find the vertex. The vertex is negative 4 over 2 times negative 1, negative b over 2a to get the axis of symmetry. This is negative 4 over negative 2. That's positive 2. So my axis of symmetry is right around there. And because of, well, let's get the actual vertex. So it's going to be at 2 comma. We're going to plug in a 2 here. So it's going to be negative. This is 2 squared plus 4 times 2 minus 13. This will be 4. Negative 4 plus 8 minus 13. And negative 4 plus 8, that's 4. 4 minus 13, that's negative 9. So my vertex is at 2, negative 9. So somewhere around there. And then because of symmetry, we know there's got to be a point over here. So this thing, it's kind of off. But we know that it's opening down, right? It's not going to be that fat. But the reason that it is because I'm counting here by tens and here I'm counting by ones. But I just want you to get the idea that it will open down. And notice it is never going to cross the x-axis. So that's really what I want you to see, is that this thing is never going to cross the x-axis. And again, the reason it's so awkward looking is because I'm counting here by negative tens and there by positive ones. So it is off, but I want you to see just the fact that it will not cross. So there are no x-intercepts. Awesome. All right, moving on. So once again, we are going to take a look at the quadratic formula. And I'm going to go ahead and highlight the discriminant, right? And I guess that looks like maybe pink or purple to you. I don't know. My camera has been doing weird things. But notice it's a different color, so kind of wrap this up. B squared minus 4ac is called the discriminant. Okay? If b squared minus 4ac is greater than 0, that means that it is a positive value, then there are two real solutions. So something like this, where you have it crossing the x-axis at 2 places, right? It could also be opening down, but just know that you're going to have 2 x-intercepts, 2 solutions. And the 2 solutions are real, and they're x-intercepts. Now, if b squared, if b squared minus 4ac, again, the same discriminant, equals 0, then there is one real solution. Okay, and that would look something like this, where it's just touching, right, at a point. It could be like that, it could be a point here, and it could be opening down. All right. And the third situation would be if b squared minus 4ac is less than 0, that means this value is negative, then there are 2 imaginary solutions. So again, something like something up there or something down here where it will never cross the x-axis. Okay, so now that we know these three different scenarios, let's look at the next page. Over here, I want you to find the discriminant and describe the number and type of solutions. So find the discriminant and describe the number and type of solutions. So here's A. We have x squared minus 6x plus 10 equals 0. For B, I have x squared minus 6x plus 9 equals 0. And for C, I'm going to have x squared minus 6x plus 8 equals 0. So I'm going to give you a couple of seconds to go ahead and find b squared minus 4ac for all of these, and then we will go over it. Okay, well, hopefully you've had a chance to go ahead and figure these out. Let's go ahead and do A. It's going to be b squared. Well, b is negative 6. So this is negative 6 squared minus 4 times 1 times 10. And again, you must follow your order of operations. So negative 6 squared, that's 36. And here I have 10 times 1 times negative 4. That's negative 40. And that's going to give me negative 4. So my discriminant is negative. So I will have 2 imaginary solutions. Okay? Taking a look at the next one. Here we have negative 6 squared minus 4. A is 1 and C is 9. So this is going to give me 36. And then 9 times 1 is 9. 9 times negative 4 is negative 36. And that gives me 0. So I will have 1 real solution. And finally, part C, we're going to do negative 6 squared minus 4 times A times C. That's going to give me 36. And this is A times 1, which is 8 times negative 4. 8 times negative 4 is negative 32. And this is going to give me a positive 4. So I am going to have 2 real solutions. So once again, I don't mean to beat a dead horse, but just remember, if your discriminant is negative, you're going to have 2 imaginary solutions. If your discriminant is 0, you're going to have 1 real solution. And if your discriminant comes out to a positive number, you will have 2 real solutions. Okay? One little last problem. This is from your book. It's example 5. And this is the question. Find a possible pair of integer values for A and C so that the equation ax squared minus 4x plus c equals 0 has, for part A, we want one real solution. All right, so once again, this is a quadratic, and everything is based off the discriminant, which is b squared minus 4ac. If we wanted to have one real solution, that means that b squared minus 4ac must equal 0. All right? So let's see what we have here. We don't have an a. We don't know what a is. We don't know what c is, but we do know that b is -4. Let's see if we can work something out. So b squared, that's going to be -4 squared minus 4 times a times c has to equal 0 in order to have one real solution. So let's go ahead and solve this. -4 squared, that is 16, minus 4ac equals 0. I want to try to solve for AC because those are the ones that I don't know. I don't know what A is and I don't know what C is, but I can move other stuff around. So I'm going to subtract 16 from both sides. I'm going to get -4 times AC equals -16. And now I'm going to divide both sides by -4 so that A times C has to equal a +4. Now remember, the question is a possible pair of integer values. So A could be 1 and C could be 4. That would work because 4 times 1 is 4. So if that is a possible solution, we can go right back up here, and for A we're going to put a 1. So that's going to be x squared minus 4x plus 4 equals 0. And that will work. But you know what else would work? If A was 2 and C was 2. That would also be a good solution. 2 times 2 is still 4. And we could have written this as 2x squared minus 4x plus 2 equals 0. So these are two possible solutions. These are the only two solutions. But you can have more than one possible equation is what I'm saying. One possible pair of integer values. So whichever one you came up with, those are going to work. Either this one or that one. Whether A is 1, C is 4, because 4 times 1 is 4, or A is 2, C is 2, 2 times 2 is also 4. So you could get either answer. Okay? Let's do another one of these because they're so much fun. Let's say we still have the exact same thing, so I'm going to rewrite it. The original equation that they gave us where we don't know what A is and we don't know what C is, but now we want to get two imaginary solutions. Okay, so again, that means that our discriminant must be smaller than 0, must be less than 0. So let's plug in what we know. We know B is -4. So -4 squared minus 4AC is less than 0. Once again, we're going to solve this as far as we can. So this is 16 minus 4AC is less than 0. I'm going to add 4ac to both sides. So 16 is less than 4ac. Divide both sides by 4. 4 is less than a times c. So here I need an a and a c that when I multiply them, the answer is bigger than 4. So obviously unlimited number of combinations, because we have a times c is greater than 4. It's an infinite solution. But let's just find one. So why don't we let a be 2 and c be 3? If that's true, then a times c is 6, and 6 is bigger than 4, so that would work out for us. So if we let a be 2, that would be 2x squared minus 4x plus c, which is 3, equals 0. So one of infinite number of solutions that would work as far as equations that we could use here. All right? And I know you are probably very sad, but we have reached the end of this lesson. Hopefully this made sense to you. If not, please make sure you see me in class and ask questions. And I will see you next time for our next lesson. Bye.